All right, now I got everything situated here. All right, I want to warn you. Do you like being warned if it's going to be like really hard, or do you just rather not know? Okay. This one gets a little, it's not hard, but the algebra is just really, really messy. So it seems hard. It does seem simple, but it's not. Okay, so today what we're doing is finding the second derivative. And the notation for second derivative is d2y over dx squared. And I kind of want to give you a reason as to why it looks like that. So in terms of the notation, when we're taking just the regular derivative of something, the regular derivative is just d dx typically. That's the derivative with respect to x. So d dx is how the first notation that we gave you for the most part, one of the notations. If you're taking the second derivative, you're taking the derivative of the implicit derivative. So you're taking d dx of dy over dx because that's the implicit derivative. So essentially when you're taking the second derivative, you're taking the derivative of the derivative with implicit differentiation. And so because you're taking this and this, when you multiply these, d times dy is d squared y, right? Over dx times dx is actually dx squared. And somewhere along the line, for some reason, they just dropped off the parentheses, but d squared y over dx squared is where this comes from. Does that make sense? So sometimes it's easy to forget where the squared is. And if you think about it this way, I think it'll be easier to remember like where it was. All right, with that said, we're going to derive this or find the second derivative of this equation right here, which does seem simple. The first derivative is pretty simple. The second derivative is where it gets messy. So give yourself enough room to write here. If you want to just put it on a totally separate sheet of paper, you may be more comfortable doing that. It doesn't matter to me. I'm going to try and fit it on here and we'll see. Okay, so we're looking for the derivative of this. What is the derivative of y squared? 2y, and then what? dy dx. Plus x times y is product rule. So you got first function times the derivative of the second. So first function is x, derivative of the second is 1, dy dx, because you're deriving with respect to y. Derivative of y with respect to x, sorry. So that's first function times the derivative of the second, plus second function, which is y, times the derivative of the first, which is 1 dx dx. Equals, derivative of 25 is 0. So dx over dx is just 1. That's gone. And then you got to think about, you have two different terms with dy dx, so we're going to factor out a dy dx. So you got 2y plus x dy dx. Are we comfortable with me moving the y over in that same step? Equals negative y. I kicked this over and left these two. And then the last step is to divide. So dy dx equals negative y over 2y plus x. Okay, that's the first derivative, which wasn't so bad, right? That's what we've been doing. Now we have to take the second derivative of this, and that's where it gets messy because it involves the quotient rule and implicit differentiation, and then we got a bunch of messy fractions to deal with. So we're going to take the second derivative, which is d squared y over dx squared. And we have to do low d high minus high d low all over low low. That's what we're going to do here. So my low function is 2y plus x. That's low. Times the derivative of the high function. The derivative of the high function is negative 1. Don't forget the dy dx. That's easy to forget on that one. So that's low d high minus high d low, so negative y times the derivative of the low function, which is 2 dy dx plus 1 dx dx. I'm going to put that in brackets so I don't forget to distribute that negative later. I'm going to let you sit and think about that one for a minute. All over what? What do I have to put that over? 2y plus x squared. I forgot to do that last hour, and so it was a mess. We'll go back and try to fix it. Okay, is there any questions on how I did that first step? Okay, so now we just have a bunch of algebra we have to simplify now, which is the messy part. And so I'm gonna, before we simplify it, I need to point something out. This is like the major step of this problem. So now we have a dy dx here and a dy dx here, but we're solving for d squared y over dx squared. So we don't want to have to like move anything to the other side. We just want to somehow get rid of dy dx. So if you look at this, can I substitute something in for dy dx? Yeah, this right here is dy dx, right? So if you substitute this in, then you lose your dy dx's, which is good because you're trying to solve for your second derivative. And then dx over the dx is going to be a 1. So we got a bunch of stuff that we need to rewrite and simplify from here. So let's do that. I'm just going to replace those with the negative y over 2y plus x. Yes, Sydney? Thank you. Okay, good catch, because we need that. Okay, when I substitute in negative 1 times this negative y, this was negative 1 times dy dx, this should be a positive. Good catch. You guys good with that? Okay, are all my other signs right? So far. Do we understand why this became minus y? Where'd that come from? Anybody know? Michael?
For the other one, would the negative 1 make it negative 2y minus x?
Nope, because that, if you did that, that'd be like taking negative 1 over negative 1, which would actually be times positive 1. You're only multiplying times negative 1. Good question. You can imagine it as negative 1 over 1 if you want to. Do we understand where this y came from? So I just distributed this y to this and to this, because that's what the derivative rules tell you to do. This is high d low. So the high function is this function times the whole derivative of the low function. So you got to distribute the y to both. That's where I got that. And then I have some negatives here, which I'm going to have to clean up here in a minute. But so far, that's what we got. Okay, so before we do anything else in terms of simplifying, I'm going to put this 2y plus x over 1 here, because that makes things easier when I start to simplify. So when I multiply these two here, I've got 2y plus x in the top and the bottom. So those can go away. And then over here, the problem is I have one fraction right here that I can't cross cancel. So unfortunately, I have a denominator of 2y plus x here in this numerator. So I need this 2y plus x to be the denominator in every single term. So what you're going to do is you're going to take this whole thing times 2y plus x over 2y plus x. And you're only going to multiply times 2y plus x for the ones that don't have the denominator already. So it's going to be times this here, because that doesn't have a denominator of 2y plus x, This technically does, because this is like 2y over 1 here. So this is essentially just one fraction. But this is going to have to get distributed. Are we following so far? Because there's one on the top and one on the bottom. And so I didn't want to have to distribute too many things. It doesn't really help me a lot, actually, now that I see it. I probably could have left it. You're going to get the same thing either way. Okay. So I'm going to come up here now because I'm out of room. So I'm multiplying every term that doesn't have a 2y plus x in its denominator times this thing here. Is what I'm doing. So I got to take y times 2y plus x, which is 2y squared plus yx. We go with that part so far? Okay. Then I've got a bunch of things I got to deal with in terms of its signs. So this times this is going to make this a positive, but this is subtracting it. You see that? So we've got a positive or negative times a negative, which is going to be positive, but then this negative has to get distributed, which is going to then make it a negative number. So then we've got minus 2y squared and then the minus y here. But this minus y is a minus y times a negative out here, these two negatives. So that's actually plus 2y squared plus xy. And this is all over the 2y plus x denominator, which again is all over the 2y plus x cubed. So it's a mess right now.
Wait, what happened to the 2y in front of
This here?
Yeah.
I just took the 2y times the y, which gave me the 2y squared. Katie?
Wait, why wouldn't it be 4 if you're distributing the 2y plus x over 2y plus x to that?
I didn't distribute this to this one
Okay.
because it already had a denominator of 2y plus x. Yes, Michael?
This is way back, but where did the 1 ever go? It says like 1 dx dx. I don't know.
Oh, that's what I was saying. This y got distributed to this and to this, which turned into this minus y here. Is that what you're asking about?
Yeah.
Okay. Anything else? Connor?
How did the 2y plus x go from the squared to the cube?
This here? Oh, it is a squared. Sorry. Thank you. It's going to become a cubed in a minute. Connor, is your head about to explode? I can tell. Okay. We can simplify this a little bit. So I've got a negative 2y squared and a plus 2y squared. So those can go away. And then I'm dividing by a fraction, so I can essentially just multiply by the reciprocal. So I'm going to do that right now. So this reciprocated is 1 over 2y plus x squared. So this is what I have right now. Okay, so I'm going to clean this up a little bit. We got 2y squared plus, I have xy and an xy. So how many xy's do I have? 2 xy's, right? All over 2y plus x quantity cubed now, because you got to multiply this by this. Okay, we can't stop here. And the reason we shouldn't stop here is because of this right here, the original problem. You could stop here on a test if it was not multiple choice, but this is how they're going to make a jump on a multiple choice test. So if you notice, we've got y squared plus xy, and I've got a y squared plus xy here if I factor out a what? 2. Okay, so if I factor this out, I get this. And now what can I do with this y squared plus xy? I can change it to a 25, right? Because that's what this is right here. So I can substitute in a 25. So this is how it's going to look on a multiple choice test. 50 over 2y plus x cubed. And this is this, the second derivative with respect to the derivative of y with respect to x, the second derivative. Okay, I'm gonna let that just marinate in your head for a minute. Does anybody have any questions about where numbers came from, where they went, what the heck's going on? Just keep in mind that when I'm up here doing these problems, algebraically, my mind may work a little different than yours. I like to keep things in brackets and then I distribute as I go. If you like to distribute everything after your first step and then have those numbers there where they want them, it may be an extra step, but if that works for you, then do that. Don't feel like because I did it this way, you have to do it that way. It's easy to lose negatives and signs when you're doing this. So whatever you choose to do is fine. Don't feel like you have to do it the same way I did it. Yes, Connor.
I was doing it, I was trying to work with it a little on my paper on my own, and when I got to the 2y squared plus yx plus y over 2y plus x over the 2y plus
This step here?
Yeah. On the top, I factored out, and so it's like 2y squared plus 2 yx, and if you factor out 2y, you get 2y.
Here?
If you factor out a y, you get never mind. Sorry.
No?
No, I just realized this.
Okay. The big thing about this problem is this step right here. When you get to your writing your dy dx, you got to substitute in whatever your original dy dx was back in, because then you can start simplifying. This last step happens sometimes, but not always. And the next example is going to show you an example where the information you're given doesn't actually help you solve the rest of the problem. The only reason this worked is because you had something equaling a numerical value. That's not always going to be the case. And that's not what's happening here. The second example is actually a little bit easier, I think, algebraically. Are we ready for that one? Okay. Ready or not? This little blurb here is only if you have a calculator that will do this, which most of you do not. Sam, by the way, do you have your graphing calculator they lent you? What's the number on it? Can you just give me that quick while I'm thinking of it? Okay, why don't you guys try to find the first derivative? I'll let you get started with that. Find dy dx. Yep. Okay, thank you. Okay, I have my work up here if you want to take a look at what I did. The big thing on this one is that your dy dx's are on different sides. So you got to move all your dy dx's to one side and everything else to the other. That's what I did here. Once we're ready to go, I'll start looking at the second derivative from here. Can you put your mask on? Did you need me to do something or you were just waiting? Connor?
No.
Did you get this?
Yeah.
Okay. Are we ready to go on? Okay, now we got to find the second derivative. So we're looking for second derivative of y with respect to x. And then we got quotient rule again. So low d high minus high d low. Low is 1 minus x. Derivative of the high function is 1 dy dx. Minus high, which is 1 plus y. Derivative of the low is negative 1 dx dx. All over low, which is 1 minus x squared. Okay, now that I have that written like that, what do I need to do? It's the key to these problems. Yep, plug in dy dx since you have a value for that. So I've got 1 minus x times 1 plus y over 1 minus x. Plus 1 plus y times 1 plus y over 1 minus x. Oh, that is dx dx. Thank you. So we don't need this. This is 1 plus y. Good catch. Can't read my own handwriting. Okay, what can I do from here? Oh, this is all over minus x squared. Can I simplify this? How do I simplify it? Yeah, this is over 1, right? So I can get rid of this, which is fantastic news because then I don't have any fractions. Okay, so then I've got 1 plus 1, which is 2, right? Plus 2y, because I have y and y, all over 1 minus x quantity squared. You could factor out a 2 if you wanted, but it's not going to do any good, really, necessarily. Like, there's nothing you're going to be able to cancel. So this is what you get for your solution.